We've been working through this entire chapter, chapter 12, dealing with circles, and we're finally going to come up with some equations for circles. So 12.5, circles and coordinate planes, all about finding an equation for a circle in our graphs. And I have the first question up there if you'd like to look at this kind of concept, but I'll skip ahead to our first description. And that's again that we can write the equation of a circle if I know two things. I need to know the center of that circle and its radius in the coordinate system. So if I do know those two things, the equation for my circle with a center at h and k and a radius of r is going to be the quantity x minus h squared plus a quantity y minus k squared is going to be equal to the square of the radius. So again, if I have a given center at h and k, I could have that center at 0, 0. H and k would just both be 0. But if I'm moving that center, I'm going to use h and k to substitute in, and knowing a radius is going to finish that equation. So let's look at that in practice to make our equation. If I want to form the standard equation of a circle with a given center and radius, and again that was what we call our standard equation, the one we just saw, the center is telling us our h and k that we're substituting in that formula. So if the center is at 5 and negative 2, h is 5, k is negative 2. If I substitute those in, I just have x minus 5 squared, and y minus a negative 2 is going to change that to y plus 2 squared. Last thing we just got to make sure of is on the right hand side I have the square of my radius. So if the radius is 7, I'm going to have a 49 on the right hand side. So again, our center is at 5 and negative 2. You just got to remember in the formula, since it's minus h and minus k, got to be careful about the signs. Minus 5 minus a negative 2 changes that to positive. But otherwise I just square my radius and I have my equation. Same thing with our next equation. If the center is given, if I plug that in, remember I'm just thinking opposite signs. X minus negative 2 is x plus 2, and y minus negative 1 is y plus 1. And we just got to make sure that if I'm taking square root of 2 and I square it, that's just going to cancel that square root sign. So I just end up with 2 for the right hand side of that equation. So again, x minus h squared plus y minus k squared equals the square of the radius. So on the back we're trying that again, but this time we have to find some parts ourselves. We are starting with the center again, so we start with h and k is 1 and negative 3. But this time we aren't told the radius, but instead we're told it passes through this point at 2 and 2. So from that, on my graph that we're given to picture this, the radius would be going from my center to that point that's given on the graph. So if I want to find the length of my radius, I have to think back to my distance formula. And for the distance formula, I subtract the x's and square them, subtract the y's and square them, but really it can be either way around. Y2 minus y1, I square that, and also x2 minus x1, if I square that, that would be 1 minus 2. So something about the distance formula is you can reverse those parts. I can take the center minus the point, or I could take the point minus the center. It looks like in my work I did the center minus the point. So the center y value minus the point y value, that's negative 5 all put together. And the center x value minus the point's x value is going to be negative 1. And if I'm squaring those and substituting those in the distance formula, I should get the square root of 26 for my radius. So if I'm trying to get the equation of my circle, remember we're already given h and k, so that's x minus 1 squared and y plus 3 squared. Remember plus 3 because we're subtracting a negative. And then for the radius, remember since I'm squaring the radius in that equation, I take the square root of 26. If I square that, I just get 26. That's going to be the right-hand side of my standard form. So trying that same type of question again with a different point and a different center. Remember, if they tell you the center, that's already your h and your k. So if they are giving you one more point, we have to use that point to find a radius. And remember, that's just another use of the distance formula. So y2 minus y1 is 3 minus 1, and I square that. And x2 minus x1 is 4 minus a negative 1. Remember, is like adding a positive 1. And we're squaring that also. And again, it doesn't matter if you take the center minus your point or the point minus the center. Should get the same thing either way. So if I get 2 squared plus 5 squared, that would be the square root of 29 as my radius. I just got to make sure that when I'm using that in standard form, remember I'm using the center, so x minus 4, square that, y minus 3, square that. That was the center that I was given. And then since we just found that the radius is the square root of 29, for r squared, I'm just going to have 29 on that right-hand side. Remember, it's r squared in the equation, not the radius itself. So last type of question is where we're doing the opposite, really. We're making a call on a cell phone. A tower transmits and receives the call, receives and transmits. A way to monitor the range of the cell tower system is to use equations of circles. So this is kind of how that very first question was set up before we started the notes. Suppose we're given this equation to represent the position and range of the cell tower. We're going to use that to graph it and also show that same position and range. So from that equation, that was our standard form of our circle. So we're just working our way backwards to find where the center is. Since it's x minus h, that h value would just be a 1. And remember, since it's y minus k, I'm not going to use a positive 2 for k. That would have to be a negative 2. So just from the left-hand side of my equation, I know the center of my circle is going to be at 1 and negative 2. And if I just remember that the right-hand side was the radius squared, I can take a square root of 36 to find that the radius is just 6. So if I know that my center is at 1, negative 2, and my radius is 6, best way to graph that is to just start at that center. So this is x is 1, y is negative 2. And if I want to form my circle, I can first just go up, left, right, and down the distance from my radius, and that would be a distance of 6. So I just went 1, 2, 3, 4, 5, 6 spaces to the right, 6 spaces upwards, 6 spaces to the left, and 6 spaces down. And a little bit harder to count 6 places diagonally, so as long as I have those 4 points to start with, you just want to see if you can draw a circle as smoothly as you can through those 4 points. You can see mine's a little bit messed up also, but as long as I have those 4 points and as long as I have the center, we just want to make sure if we can, again, a little estimate the circle. Not going to know exactly where those points are because we don't have to plug in everything, just those 4. So make sure you have these points completed and see if we can get that done in class.